So we're going to start working on computing these probabilities. So we're going to look at the formal computation, and then we're going to actually look at doing this with a TI-84 to make this go a little faster. So Pew Research Center recently reported that approximately 30% of internet users in the United States use the image sharing website Pinterest. So suppose a simple random sample of 15 internet users is taken. We want to use a binomial probability distribution to find the binomial probabilities. So we're going to talk about what a binomial probability distribution looks like here in a little bit. So we want to find the probability that exactly 4 of the sample people use Pinterest. Then we want to figure out what's the probability that fewer than 3 of the people use Pinterest, and what's the probability that more than 1 person uses Pinterest, and find the probability that the number of people who use Pinterest is 1 in 4 inclusively. So I guess that means anything in between. All right, so let me make myself a little bit of space here. Okay. So one of the things we might want to look at is what would a probability distribution look like? I'm going to do this off to the side here. So what we could do is we know in general from the information we have is that I know that I have a simple random sample of 15, so I have 15 trials to look at. And I am looking at the probability that people are using Pinterest. So the probability that a randomly selected person using Pinterest is 30%. So the probability of success is 0.3. Then we want to know this part right here, approximately like having exactly 4 people sample Pinterest, having 3 or fewer sample Pinterest, having more than 1, or having between 1 and 4. So in general, the formula that we have is, because X is changing from each question here. So P of X is just going to be 15 CX, whatever X happens to be. Then we have that P is 0.3 times X. Then we're going to have minus 1 minus P. So that is my failure. So 1 minus P is just going to be 70%. So there's a 70% chance that a randomly selected person is not using Pinterest. And then we will have N minus X is going to be that probability. So this is going to lead us into what a probability distribution is going to look like. It's going to be big. It's going to be a little messy. So I am going to do this like we did with other kind of when we had probability distributions, is that we were looking for certain kinds of events. So the first one is we just want the probability that we are going to get exactly 4 people are going to be sampled. So this is 15C4 times 0.3 to the power of 4. And then we have 0.7, and then we have our N, sorry, this is 15 minus X. We're going to have a 15 minus X. So in this case, if I have 15 minus 4, that's just going to leave me with 11 failures. But I need 4. Okay. Sorry, I just need my number again. So we are going to have 15, choose 4. So just 4 out of the 15, that is going to be 1,365. We're going to do this all in one clump. To the power of 4. And then 0.7 to the power of 11. So what I get here is the probability that if I found 15 people, and that 4 of them use Pinterest, that probability is 0.218, and you just keep on going. 86. I'm going to stop it there. So the next ones are going to get a little more complicated. What is the probability that fewer than 3 people use Pinterest? So this is, I'm looking at less than 3. So this means I need the probability that 0 people use Pinterest, plus the probability that 1 person uses Pinterest, plus the probability that 2 people use Pinterest. So that means what I need is I need to figure out all those different probabilities. So this is going to be a bit of a mess because what I need here is 15 choose 0 times 0.3 to the power of 0 times 0.7 to the power of 15, because we're going to have 0 people successful, 15 were fails. Once I figure that out, we add that to, so like I said, we figure out each one of these events separately. We could add it all together like this. 15 choose 1. Then I have 0.3 to the power of 1. And then I have 0.7, my fails. If I have 1 success, I have 14 fails. Plus 15 to the power of 2. 0.3 is my probability of success. I have 2 successes. 0.7 is my fails. If I have 2 successes, that means I'd have to have 13 fails. We're going to do a little bit of rounding here. If you did each one of these separately, the probability of 0 success would be very, very, very small, 0.00016. We'll round it to there. The probability that at least, let me do that again. I put that in the wrong place. That number is way too small. 0 is going to be 0.0047. There you go. That looks a lot better. The probability of 1 success is 0.0305. Make sure it goes in the same decimal places. The probability of 2 successes is going to be 0.0916. I have to move something on my screen here. All right, and then if we put that all together, that's going to be 0.0047 plus 0.0305 plus 0.00906 or 916. That is a combined probability. So the probability that fewer than 3 people are using Pinterest is 0.1268. Okay. I just double check my numbers here very quickly. Yes. All right, so C, so that's my B there. C, we will find the probability that more than 1 person uses in Pinterest. So this one we could be tricky about. This is where we like to use complements. The probability that more than 1 person uses Pinterest. So more than 1, that is the same as saying the probability that 1, 2, 3, all the way up to 15 people use Pinterest, or more than 1, sorry, it starts with the 2. So that means 2 people, 3 people, 4 people, 5 people, 6 people, etc., up to 15 people use Pinterest. Or the opposite of that is that we don't have 0 or 1 person using Pinterest. So we do know the probability that one person uses Pinterest and the probability of 0 people as well. So we got 0 people and 1 people using Pinterest. So the probability that 0 or 1 people are using Pinterest is 0.0047 plus 0.0305. So that's 1 minus, I'm going to have to do some clearing out to get that last problem in here. Oops, 5, there we go. That means that's 1 minus, so the probability that 0 or 1 people are using, one person uses Pinterest out of 15. That is 0.0352. So that's going to leave me with a probability that more than one person uses Pinterest. So that's 2 people, 3 people, 4 people, 5 people, 6 people, all the way up to 15 people out of 15 use Pinterest, is actually going to be 96.48 or 0.9648 as a probability. And then for my very last one, D, I think I'm going to put D. Oh, what's the color? I'm going to use bright red. We're going to use this space for D. Sorry, my board slipped. So D was the probability of Pinterest is, people use Pinterest between 1 and 4 inclusively. So that's the probability that, look at it this way, that our random variable is either 1 between 1 and 4, or the probability that X is going to be 1, 2, 3, or 4. So I need the probability of 1, the probability of 2, the probability of 3, and the probability of 4. So we already know 1 because we found it right here. The probability of 1 out of 15 people uses Pinterest is 0.0305. The probability that 2 people use Pinterest right here, that is 0.0916. So what I need is the probability of 3 people using Pinterest and 4 people using Pinterest. Okay. So if I find out those last two, oops, I'm gonna have to put this all back in here one more time. Oh, actually, we already had 4 because we found 4 right here. So it's only this one that we need. Aren't we lucky? So like I said, we already have the 4 here. So we just need that 3. So I need the combination of 15, choose 3, 0.3 to the power of 3, and then 0.7 to the power of 12. So that is going to be 0.1700. So once again, if I add all of those together, so the probability that 1 out of 15 people uses Pinterest is 0.0305, that 2 people out of 15 use Pinterest is 0.0916. The probability that 2 out of 15 people use Pinterest is 0.17. And the probability that 4 out of 15 people use Pinterest is 0.1286. So we get 0.5107. So as you can see, this is a bit of a monster. So we may want to consider looking at using a calculator to make this go a little smoother for us. All right, before we do that, I want to just talk about a probability distribution. So we can make binomial probability distributions. So if we go back to this problem we had earlier with the multiple choice exam, we want to make a probability distribution for the number of correct questions. So we can have a choice of 0, 1, 2, 3, 4, 5, 6, 7. I need to think I make a little more space here. Make this a little bigger. This is going to be a long one. X and P of X. So we can have 0 correct answers. We could have 1, we could have 2, we could have 3, we could have 4, we could have 5, we could have 6, 7, 8, 9, or 10. So once again, we could calculate each one of these by hand. So I'm kind of using a calculator to make this go a little bit faster for me. So the general formula that we have here, once again, is that we had 10 trials. The probability of success was 1/4. The probability of a fail is 3/4. So what we're looking at is the probability of any X is going to be 10 choose X times 1/4 to the power of X. And then we're going to have 3/4 to the power of 15 minus X. So I'm actually going to have this set up in my calculator to make this go a little bit faster. So we're going to have 10 choose 0. So that would give me one choice there if I do choose 0. Point. So 1/4 or 0.25. We're going to have that to the power of X. So in that case, for the first one, it's going to be 0. And then we're going to have 0.75 or 3/4 to the power of 15. Oops, there we go, power of 15 for our first one. So if we put that all into a calculator, this first probability is going to be 0.013. So I'm going to go out 3 decimal places here. So these are all approximations. If I have one correct answer, so all my X's here are 1s, then I'm going to have 0.045. If I have 2 correct answers, I have 0.067. If I have 3 correct answers, that is 0.059. So we noticed here that if I'm guessing at random, it looks like around 2 is where I kind of peak in my distribution here. That's seems to be my highest probability so far. The probability of getting 4 correct is 0.035. The probability that 5 are correct is 0.014. The probability that 6 are correct is 0.004. The probability that 7 are correct got a different answer from last time, so let me just check, see something here. Oh, okay, just a second. So this is where you gotta be careful. I accidentally put in power 15 because I was using my old calculation. So you guys gotta check this. This one is actually 0.003. So if I go back and do the other ones, 6 is going to be 0.016. If I do 5, that's actually 0.0. 0.58. Okay, I thought this was looking wrong a while back. If we have 4, that is 0.146. We have 3 correct, that is 0.250. If I have 2 correct, that probability is 0.282. So 2 is where I'm still topping off again. 1 is 0.188, and 0 correct is a probability of 0.056. Okay. And then if I finish out, so if we did the 8, that is 0.123. So this was 3.1. This is 1, 2. Okay. I was measuring out too far. That's correct. And then if we do 9, we see those probabilities are starting to significantly go down the further out that we get. 1, 2, 3, 4, 5, 6. So if we rounded that, would probably round to about here. So that is actually just how we make a probability distribution. I just go back in here. So the mistake I made was I accidentally put 15 instead of 10 there. That's how I messed that up. I was thinking back to our last problem. But all I have to do is go back in here and just change all my x's to 1s. And then I get 0.056, change them all, or zeros, and I get 0.056, change them all to 1s. Then I get 0.188. And that is how I can make these probability distributions. So we actually do make probability distributions quite a bit. What this is telling me from looking at it is I see that I kind of peak here around 2. So 0, 1, 2, 3. We kind of go up like this. And then we just nose dive right after that. So this is a very skewed distribution.